Performing function operations, part 2. Example 4, dividing two functions. Let f of x equal 6x and g of x equal x to the 3/4 power. Find f divided by g of x and state the domain. Then evaluate f divided by g of 16. All right, so f divided by g, so we can rewrite that as f of x divided by g of x. That's equivalent to f of g of x, or f divided by g of x. And so we can just write this as 6x, which is f of x, and then x to the 3/4 power underneath. Now remember, properties of exponents says that when you have the same base and you have a quotient, you subtract exponents from top to bottom. Well, x doesn't have an exponent, so that means it's assumed to be a 1. We need that to be a common denominator with 4. So let's write this as 4 divided by 4. Then again, I keep my base and I subtract from top to bottom. So 4 minus 3 is 1 over 4. So 6 times x to the 1/4 power is my function f divided by g of x. All right, state the domain. 6x is a linear equation. The domain for f of x would be all real numbers. G of x would consist of all non-negative real numbers. So if you plugged in 0, 0 to the 3/4 power would be 0. So 0 cannot be in the domain here because you can't divide by 0. So it's going to have to be all non-negative real numbers, so all positive numbers. So the domain is all positive reals, not including the 0 this time. This time you cannot include 0 because 0 would make this function undefined when you divide, so you can't divide by 0. All right, now we need to evaluate f divided by g of 16. So we've got f divided by g of 16. Okay, so there's two ways to do this. You could take each function and substitute 16 in, or you could take, you've already divided the two functions and put them together, so you could take this and substitute in just the one time. All right, so this would be basically 6 times 16 to the 1/4 power. Remember, you've got to do powers first before you multiply. So I've got to evaluate 16 to the 1/4 power. So basically, what is the 4th root of 16? What times itself 4 times gives you 16? And the answer to that is 2. If you're not sure about that, you can use your nth root key here, or you could raise it to the 1/4 power, either way. So you could do 16 raised to the 1/4 power. Or you could do the 4th root, so you have to type in a 4. Math, go to x root, which is 5, and then type in 16. Remember, the 4th root of a number is the same thing as that number to the 1/4 power. All right, so 6 times 2 is 12. So again, if you graphed this function, 6x to the 1/4 power, you would find 1612 would be a point on that graph. Example 5, performing function operations using technology. Let f of x equals the square root of x and g of x equal the square root of 9 minus x squared. Use technology to evaluate f plus g of x, f minus g of x, f times g of x, and f divided by g of x when x equals 2. Round your answers to 2 decimal places. All right, so if we use our TI-84, you know that the TI-84 is awesome and it does a lot of things, But for this one, it doesn't allow you to put in f of x and g of x. It just says y1, y2. So there may be a way to use this, but I know that Desmos calculator works very well for this. So let's look over at the Desmos calculator. Make sure you have f of x equals the square root of x written down and g of x, the square root of 9 minus x squared. And then we know that we want x to equal 2. So that's what we're going to put into Desmos. All right, so first put your two functions in. So f of x, and then equals the square root of x. So you can see it graphs it as well. And then we've got g of x equals, and then we did the square root of 9 minus x squared. So the square root of 9 minus x squared. So that graphs our two functions. You can see where they intersect and all that good stuff. But we want to find f of 2 plus g of 2. All right, and you can see that it gives you this answer right here. And it said round to 2 decimal places. So f of 2 plus g of 2 is about 3.65. And I probably should make those more squiggly, make that approximately 3.65. And then all I have to do is like come down and I can do f of 2 minus g of 2. And that's going to be about negative 0.82. So f minus g of 2 is going to be about negative 0.82. Again, I'm going to make those, since I rounded it, those are not exact. All right, and now we need f times g of 2 and f divided by g of 2. And that's going to be about 3.16. And then the last one, we're going to do f of 2 divided by g of 2. And that's going to be about 0.63. Round your answers to 2 decimal places. So we used technology to find all of those. And again, there may be a way in the TI-84. I have not played around with that, but I do know Desmos makes it very easy because you can type the name of the function in. And since we typed in f of x and g of x, then it allows you to do all of those function operations very quickly and easily. Example 6, modeling real life. For a white rhino, heart rate and beats per minute and lifespan in minutes are related to body mass m in kilograms by the following functions. Heart rate equals 241 times m to the negative 0.25 power. Lifespan equals 6 times 10 to the 6th power times m to 0.2 power. Find r times s of m and explain what it represents. All right, so you can see the 6 times 10 to the 6th power. This is written in scientific notation. So let's try to leave it in scientific notation as we go. But we're going to do r of m times s of m. All right, so go ahead and write down your functions. So 241 m to the negative 0.25 power. And then we're going to multiply that. I'm going to use brackets since this is already in parentheses here. So 6 times 10 to the 6th power times m to the 0.2 power. All right, so that shows that we're going to multiply all of that. We can use associative property and regroup this. So let's go ahead and put our numbers together. So we got 241 times 6 times 10 to the 6th power. And then we've got m to the negative 0.25 power and m to the 0.2 power. All right, so scientific notation. So we can multiply these numbers here together. So let's do 241 times 6. All right, so we got 241 times 6 is 1446, and we're going to leave this in scientific notation. So we're going to write this as 1446 times 10 to the 6th power, and then we have m to the negative 0.25 times m to the 0.2, same base, keep the base, add exponents. So negative 0.25 and positive 0.20 is negative 0.05. All right, so this would be our answer, but if we want to rewrite this more, and like this was in scientific notation, but we need to put this number between 1 and 10. So if we move this over to the left 3, that means this one gets 3 larger. So we're going to rewrite this again as 1.446 times 10 to the 9th power. And again, if you need to review scientific notation, I don't know if I think that's maybe 7th, 8th grade now when you learn scientific notation, but remember, when you move this decimal over, this number gets larger. If this number gets smaller, they go in opposite directions, but this number gets smaller, this number gets bigger, or vice versa. So it just kind of accounts for that. Now it says, what does this represent? So what is the heart rate times the lifespan? What does that actually represent? So if you multiply these two numbers together, that would represent the total number of heartbeats over the lifetime of the white rhino with a body mass of m. All right, so that is all for lesson 4.5. If you have any questions, please let me know.